Okay, welcome back to How Now videos. We're taking a look at passive solar design. We're taking some information from Building Construction Illustrated, a textbook which I highly recommend. I'll have a link for that in the description of this video. This is a kind of a diagramming tutorial on the different types of passive solar design, such as direct, indirect, sun space, roof pond, isolated gain, focusing a little bit on those construction details, but even more so on the materials and the methods involved. So once again, more of a diagramming lesson here. Diving into it, you'll see that I have a few models pre-made here, and we're going to modify these to then represent the different types of passive solar gain. So here in 3D I have them. I'm going to show my sun path on so that way I can see where the sun currently sits, and this can be modified by changing the dates, the calendar date here, and also the time of day to influence this. I like that it's set in a winter month right now at about midday, so we can kind of see how low that solar solstice will be at the noon position in the middle of the winter months. When I have my shadows on, I can see the shadow that's cast on the north side of my building at this time of day as well, so it allows me to have a little bit more control on analyzing how my site might affect someone else's or someone else's site affecting mine as I go and design this. I have section views created. So this first section view is we're going to diagram direct gain here, and so here we're basically looking at the north side to our left, the south side to our right. So this is a west elevation that we're looking at on our home, or I should say like a west facing section. And coming from here, we can show a few details here. We can show the influence of an awning that would have on our gain and our shadows cast on our structure. But the idea here for direct gain is that our flooring material needs to be, and our wall material that is getting this direct sunlight, this radiation heat from the sun, has to be 50 to 60% of the total surface area inside. So I could do like a nice stone floor here, and to actually edit the type of our floor, then let's go and take a look at the different materials that would need to be built with in order to get this type of slab on foundation floor that allows for this absorption of the radiation heat from the sun. So under my function here, we're going to just go and create a few more layers. Our core structure here, let's make that all the layers that make up our concrete pad. So going into that structure category, let's take a look for concrete. Cast in place gray is just fine. I'm going to say okay on that. And we see our thickness on this. We're going to go with the minimum thickness of 4 inches, just to define the minimum. You could go 6, probably a little more common, but I'm going to go the minimum on this. I'm going to insert and send down inside the main core structure. We're going to go with a plastic. I'm going to go with a 6 mil moisture barrier here. And I'm just going to call it my vapor retarder. We could do like a polystyrene as well. I think that would be fine too. So polystyrene, and we'll say okay. And that's going to be a membrane. We'll see if Revit lets us actually put that in here under the core boundary. It might come up with an error, and if so, we'll just send it down outside the core boundary. And then below that, let's insert 2 inches of sand. One of the more exciting materials in Revit. And then let's insert another material, and we're going to call this finish. It's the outside here. And we're going to go 6 inches of gravel. Also one of the more exciting materials that Revit has to offer us. And let's make that 4 inches of gravel. And this helps stop the flooring material from wicking up moisture from the earth. And it creates that break right there for us. Now on top of this cast in place concrete, it would actually work well if we wanted to have the concrete floor as our finished floor for the absorption of radiation, but we can go on top of that another finished like tile or stone. So let's just insert up above that, whoops, a finished material. Let's just look for like a stone floor, and to set these you would have tile set, and we can go with like a travertine. Click on that. I mean, you can have your thin set, and you know, make sure that you're solid. If you have any kind of movement in your subfloor, you'd have some cracks, but here we should be all right. And people might even want to go with like some kind of level of insulation then between your floor and your finished floor. We could even insert that insulation, like a rigid foam insulation, just below that plastic. That should be fine. So if we go and we insert in a 2-inch rigid foam, rigid insulation, say OK, and say OK on that. Face layers must have a thickness. Where did I forget? And right here, let's go with like a 1/2 inch. Depends on the product. Let's see if Revit likes that. It likes it. We're going to want to edit the name on this. And I've just overridden this. Really what I should have done was at the beginning duplicate that. But let's just call that stone floor slab on grade. Okay. We have our layers. If we want to see those layers, let's go to fine detail so we can see where we landed. Okay, and we're going to have our tile on top of that. Now this surface is taking up a good amount of room here for our direct gain. If we edited the footprint of our awning here, we could say more or less of this awning. We have a 1 foot overhang right now on here. If this overhang was too much, just to illustrate a point right now, let's just see how that affects our section view. And if we had our shadows on, maybe we could see this a little bit better in the shadows cast in level 1 right here. So really not being affected too much. Our sun's been able to go low enough to get that. And let's see if we can see our shadows being cast and in 3D. Take another look at that. Really not being affected too much here by this January sun. Let's mess with the months a couple times. February it starts to get higher. Let's try December. See where that lands. Still kind of low as well. So we can mess around with time of year to also get a pretty good study on this. Okay, so section 1. We've made our material. Same thing with this back wall. We would want to make that out of stone as well. We could turn that to like a retaining 12-inch concrete wall here. And here I have a just quick way, a masking region to just hide out I could have also dug that out, excavated that with a massing and site tool, and you could basically trench in a building pad into this location, and then I wouldn't have to use the masking region. That's a quicker way. Alright, now this wall here pretty much needs to become a curtain wall. So in level 1, let's turn this into an embedded curtain wall to allow all that sunlight to come through. So if I go to curtain wall, and I can do one that already has all the mullions on it, make it a little bit easier. There's a quick way to throw that into an existing wall. We can embed it. If we go to edit type, we can check automatically embed, and if that's checked, then we can throw that into an existing wall. If we don't have that checked, we would need to kind of redraw that curtain wall. So now here we can see that it's already put into my model. So going into 3D, we can see that we have this storefront that's then allowing our sun to come in here, and we can see how the shadows are cast on here quite nicely, hitting a lot of that stone floor that then is going to capture and keep that radiated heat from the sun in on our structure as we go through the day, which is real nice. We can even adjust that overhang and say, let's make that, a little bit more reasonable. Check that off. And so that's our direct gain. Let's go to an indirect gain study real quick. Highlight these, and let's just hide our elevations here. And once again, kind of same orientation. South side over here to the right, north side to the left. An element that we forgot to put in direct gain was a vent, and that's going to be an indirect as well. Think of indirect more so as allowing that solar energy to be absorbed and then moved through the space using conduction. Very, very similar to direct gain. So essentially we're going to have almost like a trombe wall here to absorb that heat and then radiate that out into our space, where direct gain was more so like the actual floor and walls of our structure, where this is going to allow a little bit more conduction to just kind of pass this through. Not necessarily convection where air is moving through. That's going to be more isolated gain. So very similar, but not to be confused with it. So for this one here, in level 1, for indirect, we'll throw in our venting window. And we wouldn't want to fix one, to be honest. Probably do like a hopper window. Or even a transom would be great. Still, height is going to be pretty tall, so we won't see it in this view. Throw a couple in. And same thing here. We want to see these in the view. Section 1. Oh, this guy is in the earth, so we can change that a couple different ways. But we're throwing that up there for venting, and then I can match the height on that later with the other windows that are in this one here. I'll just throw that up. And those ones, my walls are a little extra tall. Now here we're going to throw in our trombe wall. So in level 1, indirect gain. I'm going to go to wall, and we're going to choose a stone wall. It can be a concrete wall, it could be like a brick wall. So why don't we just go with like generic 4-inch brick. We'll edit the type on that. We'll duplicate, and let's just call it like an 8-inch. If it's 4 inches, it's technically not a structural wall, it's just a veneer. So we need to go a little bit beyond that. I think 4.5 or 5 is the requirement for a structural brick. Otherwise it could topple over. So let's just go 8-inch brick wall, and we'll edit the structure on that, and basically let's insert another brick. And these would be tied together through the mortar about every 2 feet up and every 16 inches in lateral width. And there she is. Now with this basic brick wall, we can go and we can throw that in close to the south side. We want this trom wall here to be receiving radiation heat through the window. And I'm going to give it a little bit of a break on the ends, a 3-foot break. 4 is fine. 4 is fine. 4 is nice, because then it doesn't feel like a hallway. And do I still have my gap here? 35. I do not. So why don't I make this? Why don't I do some math? 4 feet. 39. Let's just make sure that I did this right. There we go. Okay, so we have our trom wall. Now if we take a look at it in 3D, there's our first one. Here's going to be our second one. We're going to repeat. We're going to put in this glass. I'm going to show you it from a curtain wall. Whoop. Don't want to create a whole system. It creates a bit more complications. I'm going to do a wall. Scroll down and find the curtain wall storefront. And when I go to draw this in from a top view, it's pretty easy. But I can go and if I'm doing it embed it, I don't have to be all the way through the wall. Like I had changed it here with the type selector. Here I can just embed it, and I can go at any height I really want. But now I have this kind of this corridor, and in level 1, I can even go and dimension this, create this hallway. You know, like let's go like 3 feet. We can do this hallway that's on the outside of our structure that then captures all this sun, and then now this radiates off into our house after the sun is set. So we have the thermal insulation here, but the heat can pass through with radiation. So that's indirect gain, and our windows then you'll see in the section passing through. Okay, this next one is going to be a sun space design, and so what we see here is we have a trom wall basically that is our exterior wall rather than on the interior, and instead of having a glazing on the exterior wall, we actually have just added on a sunroom, and with that we then have this trom wall that absorbs the heat and retains it, and then we're going to have a series of windows below and above, which allows for a little bit of convection. So not only do we get radiation, but we get some convection, and that's how we can use this sun space to kind of gather heat, and then we can create movement with that heat into our space with those two types of properties. So going into our third section view, I think I need to edit the boundary on this real quick to extend my floor underneath the sunroom. So let's do that. We'll do a little pick walls, pick them up, pick them up, pick them up, and then do a little corner tool on the end here and say unjoin, and then we're just going to have to snap nicely to our ends and check that off to have that extended. Let's go and take a look. There it is. Beauty, we have a floor underneath it. Section 3, we're going to go and add in, notice I already made this a brick wall here, or a masonry wall. I've made the sunroom. I just did a roof and changed the type to be 3/4 inches of glass above it, and it wouldn't really be one solid piece in real life. It'd be broken up into some smaller segments, and it will have mullions or even some rafters just kind of exposed coming down underneath it. to add some kind of support there. That's too long of a span to actually be like that, but this is more of a conceptual drawing here. Now I need to throw in some windows or some cutouts here on this Tron wall. So under level 1, I'm going to go under architecture window. I'm going to do the same kind of transom window, but I'm going to do just a series of them at 1 foot and just throw those in. It's basically just telling me right now with a little heads up noise that I can't see what I'm throwing in this view range. And if I want to change that view range, I can click off of here and I can go down to extents view range and just say, hey, I want my cut plane. Oh, I'm in the ceiling level. Hold on. Floor plan level 1. And same process though, view range, edit. And our top, let's just say that's at 9 feet. And then let's just say our cut plane is at 6 inches. And say okay. And then we should be able to, I don't know why I don't see that. Well, because I'm cutting below it. Okay. And then I threw in 3 of those. Those 3 guys right there. And 4, 6 to the center. That's great. So they're all centered, which is nice. And then I can throw in another set of windows, but at a higher sill height. So let's just say 6. Come on, work with me. Let's go with 6 feet. My num lock is on. There we go. And throw it in. Center it. Throw it in. And if I wanted to see this where I was throwing them in, we can go to that view range again real quick. And I know I have a sill height of 1, so I can say, let's do our cut plane at 2 feet. Alright, we can see the windows there, and then we could also change that cut plane to be at like 9 feet, or I could just go to a ceiling view to be able to see the other one. So let's just go to ceiling level 1. I can see the other ones now. Okay, so 3D, there we go. I could even move these higher. Sill height 8 foot, and then now I have even more room for air circulation. And so that's using sun space. Roof pond, we could change this to a flat roof. I'm going to actually edit the footprint on that, and I'm just going to delete out this, and let's go to level 2 to edit this footprint. So for a roof pond, essentially what we're saying is we have like a flat roof, and typically a ½ inch of rise for every foot of run is what you see on that. And so it almost looks like a flat roof, but it's not completely flat. And if we click on this here, let's go 0.5 inch. There's our rise, and let's take a look. Boom, there it is. Okay. And for this pond here, we'd have to have like a parapet wall, or these walls kind of coming up. And let's in that base constraint level 1 apply. Okay, cool. So now we have this conceptual idea that there's going to be water sitting on top of our flat roof. It would pitch towards where we would want to have potentially a drain. Now they're showing insulation panels being brought on. Just think like a pool with a solar radiation cover. Same idea. We're using the water as just a mass that can absorb and retain heat from the day. And then we can cover that up and insulate it at night, so that way that heat goes downwards towards us. We can do the opposite in the summer. We can let that heat escape out, keep it covered, let the heat escape out at night. So then the last one is isolated gain, and it's very much like having an indirect gain, but we're actually taking the heat from outside and then bringing that into our structure. and then allowing that heat to circulate, and we're using convection basically to draw heat up through our structure, and then it'll cool, fall, and land and come out of our structure. So going to our fifth section on that, we'd want to go and show a way for heat to enter our home. So it could be like a big slab of, let's say, rock that comes in and has been heated, or even like water, a source of water, and then kind of isolating our floor from that so that heat can go and travel past around it and through and out of our structure. Really kind of atypical, in my opinion, for us to be able to see something like that. So I'm going to do that with a model line or a detail line. I think I'm going to just go detail line, be a little bit easier. So under annotate, detail line, go and draw this path through the structure, and just kind of draw like a mass or a pond that would be sitting out on the south side of your home, and then we'll kind of draw that kind of site. And then from here, we'll use a masking region with an invisible line border to just show that we've isolated our floor from this so heat can move around it. So there's like a thermal break there. And then we'll go back to detail line, and this doesn't necessarily represent a floating floor, but it does represent a floor that has sections cut out of it, then allows heat to come up through here, circulate down and back around. And so this isolated spot is what's getting the heat. And so we can even edit the footprint on this roof to have more of an awning now. And so now we can say that this area is completely shaded from the sun. We're getting heat gathered in here. The heat's coming in nice and hot. It's rising through and then falling. And as this cold returns, we don't want it to intersect right here. So I do need to actually drop this in a little bit deeper and have room for separation here. And so I'm going to just take these elements right now and just drop them down a little bit further to then allow a little bit more structure to be taking place here, to allow some separation between the heat intake and the cold output here. And so to do that, I'm just going to come through and draw one more separator here. So coming down and through. We have to come a little bit lower even. And this is important. And you can see why this is not a common type of thermal insulation or a passive heating element, because it's just, you know, atypical. So hot, heated, brought in. Roof is heating and vented up at the top and the side to allow air to keep escaping up. You know, as the sun hits our roof, it automatically creates a draw because our roof gets so hot, so it's automatically pulling up. So it's going to pull up our heat here too, and through, and our cold air is going to fall and come back through our channel and kind of circulate, almost like making our house like one big radiator. Alright, don't forget to save and subscribe. I hope you enjoyed this video. I guess the last thing to note is that this kind of cavity floating in our structure becomes this kind of a battery bank of heat storage. So as that heat comes by it, we're capturing that heat and containing it here, and then we're kind of circulating through. But yeah, hope you enjoyed this video. Kind of lengthy, shows a lot of different things, a lot of different ways to annotate passive solar design into our buildings. So hopefully this helps everybody clarify some of the things that they can start to detail out conceptually in Revit. Don't forget to save and subscribe.